Hi, so today I want to talk about axial length. So what's axial length? So this is your eye and here's the eye looking that way, and the axial length is the distance from the front of the eye to the back of the eye, and it's this distance that determines whether the image is going to fall in front of the lens or behind it, which would make you either short or long-sighted respectively. So when you look through an autorefractor, they're measuring the axial length to determine are you long or short-sighted, and what glasses do you need. However, the interesting thing is that it's a little bit more complicated than we think. It's actually not an exact science, and certainly not one size fits all, especially in children, because obviously their eyesight is developing and changing, their eyes are growing. You know, there is a rule of thumb that a progression of 1 millimeter means you're going to add 3 diopters of minus whatever. But then again, they found cases that completely contradict that. It's possible to have quite an elongated eyeball and still be completely emmetropic. Emmetropic, that means 20/20 vision basically. It's also possible to have slightly shorter eyeball and to be a bit short-sighted. So it's definitely not an exact science. So I looked at 3 things that could affect the axial length. That was dry eye, convergence, that's where your eyes come together to be able to read, and accommodation. So accommodation is being able to look from near to far, being able to flex your eyes in any forward backward direction. The dry eyes, that actually didn't have any significant effect on axial length, although it did affect corneal thickness. Convergence was interesting because a study was done on that in the 90s, and it did look from the results as if convergence, doing this to read, which I'm not doing because I've got an occlusion, affected axial length as much as accommodation. So I don't know whether you got the lengthening of the axial length from accommodation plus the lengthening of the eye, from convergence, or whether it's just one and the same. So I don't know whether it's double or a bit more or what, but it was interesting to find that it looked as if convergence was as significant as accommodation in how it affected the axial length. There was also a study where people had their eye covered by a +3 lens, and what they did find was that even with +3, which would be strong readers for most people, your axial length still increases significantly when you're looking, say, about here. So it still has the same effect even if you got strong readers on. Now, something I found a little interesting was that with single vision, single vision makes axial length a bit less. So obviously convergence does play a part there. So when you're getting your glasses, say if you've got minus glasses, you're probably going to get a little bit more so that your eyes can come together, which because what is happening is when your eyes are coming together, your eyeballs are elongating and you're getting shorter sighted, so they give you a bit more minus. So that is very interesting. And from my own personal perspective, now that I've covered one eye, which is, it's not all of the time, but when I'm doing certain things, I've got one eye covered, and it really is allowing both eyes to relax. So that does explain it. So yeah, that was really what I wanted to cover. This is just an overview. I think it's worth talking a bit more in depth about the research, but that is for another video. Anyway, please like and subscribe, and hope to see you in my next video.